myself and my life. You should. Oh wow.
Kinematics. Physics. Displacement, velocity, and acceleration.
Ah, easy.
Yeah. Do you think? I don't think it's easy.
Give me a second. Oh, so this question, so like questions on this test.
Right. So, as with differentiation, velocity is the derivative of displacement, and acceleration is the derivative of velocity, or the double derivative of displacement. So it's just back the other way. So if you're given acceleration and you want to find velocity, you antiderive it. If you're given velocity and you want to find displacement, you antiderive it again. Okay, so yeah, so we'll just go straight into some questions, I think, because we've learned all about velocity, displacement, and acceleration. So. Right, so a body starts at 0. A body, like a point, a particle, or whatever you want to call a car. Call it a car if you want to. So starts at O or 0 and moves in a straight line. So you can just picture like a point moving along an axis. So it moves in a straight line. After t seconds, its velocity is given by v equals 2t minus 4. Find its position x in terms of t. So find position x, oops, terrible x, in terms of t. So whenever we're talking about position, that's its displacement from O or 0. So we're given the velocity formula. Quite obviously, we need to just antiderive it to go back to displacement. That's all we're doing. So we'll do the integral of 2t minus 4 d what? T, good. dt, because we're talking about t. And that equals, so we add 1 to the power, take that over, so it'll be t squared dt, because t is what our function is. Your letter there is whatever letter's in the function. So there's a t in the function, so it's dt. If there was an x in the function, it'd be dx. So minus 4t plus c. Right, the question, we need to find what c is because that's not a full function. The point starts at 0. So at t equals 0, what's its position from O? 0. So c is going to be 0. Yeah. So c equals 0. Therefore, you get x equals t squared minus 4t. Right, find its position after 3 seconds. Which is quite easy. We've got our displacement formula. What might you do to it?
Sub in 3.
Yep, sub in t equals 3. So 9 minus 12. So it's at negative 3. C Right, find the distance travelled in the first 3 seconds. Now, when I first read this, I'm like, oh, that's easy. It started at 0, now it's at -3, so it's gone a total of 3. However, it moves in a straight line, but it can bounce back and forth. It can stop and go back the other way. So we need to check that it check basically where it stopped and gone back and forth. So what would those points be called? Right. Not asymptotes.
Stationary points.
Stationary points.
I was thinking that, but I was
yeah.
wrong time.
But would you be talking about the stationary points of the displacement function or the velocity function? Velocity. Because we want to know when its velocity is 0. Just put this down here. Right, so we want to know when velocity equals 0. So we're going to make v equals 0. And obviously 2t equals 4, so t equals 2. We want to know its position when, because we're looking at like how far it's traveling. So we need to know where it's actually at t equals 2. So then we use our displacement function there when t equals 2. So 4 minus 8, it's at -4. So if we kind of draw a little graph, I probably shouldn't start at 0 there. 1, 2, 3, 4, 5, 6. So start at 0 here. So -1, -2, -3, -4. So the position starts at 0, and then it goes at t equals 2. It's at -4. So it's traveling this way, and then at t equals 3, so a second later, it's at -3. So it's actually turned and come back around to there. So it starts at 0, goes all the way to 4, and then goes back to -3. How far has it travelled? 5. Yeah.
Is there a unit for that, Miss, or do we just say 5?
We'd say 5 units. We don't know what the units are. So 5 units. Okay, next is to find the average velocity in the first 3 seconds. Find average velocity in the first 3 seconds. Now, average velocity is what over what? Displacement over time. What's its displacement at 3 seconds? -3. And how many seconds has it taken? 3. So -3 over 3. So average velocity equals displacement over time. And it's gone from 0 to -3 over 3 seconds, so -1. If our units were like meters, it'd be like meters per second. And then find its average speed. Now, what's the difference between speed and velocity?
Velocity is direction.
Kind
Velocity
of.
is a change.
Plus physics.
Average velocity is displacement over time. Average speed is, we wrote it down, distance over time. So how far did it go? It went 5, yep. So average speed equals distance over time. It went a total of 5 units over 3 seconds, so that's it, 5 over 3.